Right boys, I am going to try and burn several different metals so we can see the difference in reactivity between them. Wow, that one's got a mind of its own. Firstly, well, let's do copper. Copper, let's have a look. It is a sort of orangey sort of colour. Let's whack it in the burner. Burn it, burn it. I don't know if you can see, it's a glowing red. I'm going to have to take that out. That's definitely darker than it was, isn't it? That's definitely gone darker. Give it a good old heat. And look at that. Well, it's just gone black. So something's happened. Something has happened to it. It has reacted with oxygen, but it's just reacted quite slowly. Pop that there. Right, let's give it a go. This iron. Big chunk of iron. Pop it in there. Well, there's not a lot happening with this, not a lot going on with that. Right, let's... Actually, that might be because it's such a big chunk and the heat can just conduct away down it. It might be stopping it reacting, I don't know. Let's have a look at it. Well, I think it's gone dark at the end. The one end's darker than the other. Actually, let's try this stuff here. This is also iron, but it's got a much larger surface area. It's called iron wool, and it's just sort of very thin strands of it. It's the same stuff though. Let's have a look. Yeah, that makes a difference, doesn't it? I mean, iron definitely reacts. It definitely forms iron oxide. But to do it, you've got to make it in sort of very thin strands. Not a totally fair test, really. Not a fair test, but we can see it, and it is still reacting, still doing its own thing. Freaky. Right, let's try this one here. Magnesium. Will that react with air? No, not really. Oh, yes! What? 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 Oh, my eye! I can't actually see. I've got a green spot in front of my eyes. I can't see. Oh, there we go. Done. Finished. So you can see, magnesium is definitely very reactive. Iron and copper less so. If you want to get iron to go, classic example, increase the surface area, makes reactions go better. Okay, so I've decided to get some iron wool, and we've seen what that's like. It burns quite well when it's very thin, but I'm going to burn it in oxygen, which has got a lot more oxygen than air. Oxygen is 100% oxygen. The air is only 20% oxygen. So I'm going to heat it up here, and I'm going to pop it straight into the oxygen. Gotta be quick. Don't mess it up. Don't mess it up. Ready, steady, go. Yep, that burns a whole lot better. No messing about. I would like to do magnesium, but I think magnesium, you've seen what magnesium's like, we can't really be doing magnesium. Oh, sorry. Can we do magnesium? Oh, we can do magnesium. Let's do magnesium. Let's see what that does in oxygen. Yes, of course. Let's have it. Right, got some magnesium here, tied on there. Same deal. I'm going to plunge it into the oxygen to see what it does. Don't mess it up. Go on! And I think that's it. We've got no more metals. We do have this one here actually. This is sulfur. It's not a metal. It's not a metal, but it does look quite good when it burns. So I guess we should burn it really. It'd be rude not to. Right, so I will burn some. Boys, this is poisonous stuff. This is horrible stuff. It's basically the stuff on the end of matches. You might want to. Okay, so this is not a metal, it is sulfur. I'll burn it here, and let's have a look. It really smells when it burns. You can see it sort of melting at the moment. It's melting, and it should, after a little while, it should ignite. Can you see? Oh, it's got a little blue flame. Little blue flame. Oh, isn't that nice? And you can see that the sulfur also burns really, really well in the oxygen. Makes sulfur dioxide. It's really poisonous. Definitely leaving that aside for a while.